For this fast API lab, first we need to install couple of packages. First, what you're going to do is we'll create a virtual environment for our lab. I've already done that. Make sure you create a virtual environment for your lab, and you need to activate it. And once you activate that, you should do pip install fast API all. So this basically installs fast API library, and since I have it already installed, we'll just proceed ahead. So what is the goal of this lab is to make you familiar how you can expose your machine learning models as an API. Uh, what I have done for this lab is I have just built a basic API for the iris data. So I have built a decision tree model, and I have made the endpoint like the prediction function as an API using fast API. Just to give you an overview, uh, I have defined the files inside the SRC folder. The data.py file basically creates the data. Creates the data from scikit-learn and then splits the data into xtrain and ytrain. And the train file is I'm just creating a model using the decision tree classifier, and then the predict function uses the model saved in the training file to predict what is the given input. So this is just an overview. We'll be focusing mainly on main.py file for this lab. We'll import the fast API from the fast API library, and I have imported a couple of other files which we'll go through now. First, what I do is I define an instance of the fast API class. Using this instance, you will make sure that your fast API app is up and running. After that, I have defined two data models, uh, which are which will be helpful in doing validation. Let's go through one by one. First data model is the iris data. I have defined which has petal length, sepal length, petal width, and sepal width. So these are basically the inputs which the user will give. So if you want the user to give certain set of inputs, you define them in the data model. What is the data type and what is the feature name? So why you should do this? Because once you define the data model and use them, it basically does a couple of things for you. It makes the input as a JSON format, and then what it does data validation. So let's suppose for the petal length, if the user enters a string, let's say hello, it will automatically validate that, and it will say that it is an error, 422 error, because you can't enter string here, in which case I expect a float value. And it also does automatic data conversion. Let's say if I enter 2.3 as a string, it converts that string to a float value. So this is the iris data model. And we also have the response model. Response model is that how I want inputs, how I want the output in a particular format. I want the output as an integer. That is why I have defined as an integer in the response model. So we'll be using these two models for our inside our API. So we have two API functions defined over here. The first API function is app.get slash. This is just basically a home page to check if the API is up and running. And we also have given a status code as 200. Okay, 200 HTTP means that the status is up and running without any issues. And this is just a simple validation to see if your API is up and running when you go to the home page. And the next thing is I have a post method where I define the endpoint. After followed by the backslash, I enter like what is the endpoint name should be. If I enter predict, so if I go to localhost slash predict, it will hit this endpoint. So I defined here the response model inside the decorator, and I want as I said earlier, I want the output in a particular format. That's why I define the response model here. And I define the functions as asynchronous because if you don't define function as asynchronous, the process has to wait for each and every steps. If you define the function as asynchronous, what you're telling the code is that you can process other steps while without waiting for other tasks to be executed. So it basically, when multiple people are using it, it saves a lot of time without putting them on hold. And I define the data model for iris data inside this, and I encapsulate my main code inside the try and exit block. So inside the try block, I define the instance name, like the instance name that I have defined here for the iris data iris features. You need to give it like this, since you have defined the data model for the features. So I give iris features dot petal length, iris features dot sepal length, iris features dot petal width and sepal width. And once I have defined my features, what I do is I go and make a prediction. So I call the predict data, which I have defined inside the predict.py file, and then I pass my features to it. Once I get back the response, what I do is I use the data model that I have defined above, iris response data model, and I make sure that the prediction output is in the format that I have defined above. So if I have any errors, what the except block does, it catches that and says like what is that error that I'm making. To make the server up and running, what I do is that I go into the src folder, and inside that I type in uvcon main colon app hyphen reload. Main is the file name of my FastAPI file, and app is the instance that I have defined above. If you have given some other names, change it accordingly. And hyphen reload is, you shouldn't give it in the production times. It's just for testing purposes. Once I hit enter, I'm opening the browser, and as you can see that the status is healthy, like how we have defined our homepage should look like. So this means that everything is up and running and there are no issues. In order to check the prediction endpoint, what you can do is you can go to /docs, where FastAPI provides documentation of all the API endpoints that you have listed over there. And once you hit the drop down, and once you click on try it out, you can see once you click on execute, you can see that the status code is 200 and the response is healthy, like how we are defined above. In order to make a prediction and see, what you can do is click on the drop down and click on try it out. And inside the request body, define the values that you want to use. I'm just giving some random values. And once I hit execute, I can see that the status code is 200 and the response is class 2. Like this is how you will expose your model as an API. So what you'll be doing in your assignments is that you will make sure that when you deploy a model, you'll wrap it as an API using Fast API, and then you will make this prediction endpoint accessible to others. So we later in other labs we'll see like how you can make this response interact with the front end like Streamlit or Gradio, where you can take this value to and show it in the front end. And we'll be deploying this later in the Google Cloud or other cloud providers of your choice. You can also use other testing methods like Postman. This is also an API testing tool. If you don't worry about it. If you have Postman, what you can do is, again, you can go and create a post request and you can type in the IP address. For us, it is localhost/predict, and you enter what are the parameters for your body. And once you hit send, you can see what is the response. This is just another way to test if your API is working.